You type a prompt, and a second later, a perfect paragraph appears on your screen. What you do not see are the millions of arguments, corrections, and silent deletions that happened in the millisecond before that text arrived. The machine did not just generate an answer. It wrote a bad draft, recognized its own mistakes, scolded itself, and rewrote the response to please you. We have quietly entered an era where AI is editing its own mind, and humans are slowly being locked out of the room. For years, the secret engine behind modern artificial intelligence was cheap human labor. Thousands of contractors in developing nations sat in front of screens for hours, rating AI responses, correcting grammar, and filtering out toxic content. This process, called reinforcement learning from human feedback, was the only way to make raw models safe for the public. But we have hit a hard wall. Human editors are too slow, too expensive, and frankly, not smart enough to grade the next generation of technology. How does a human contractor with a high school education verify 1,000 lines of advanced cryptography, or judge whether a highly specialized clinical-grade diagnostic is medically accurate in real time? They cannot. The human in the loop has become a bottleneck, forcing developers to make a radical choice. Let the machines teach themselves. The blueprint for this shift was drawn 30 years ago. In 1996, computer scientists formalized a theory of reinforcement learning, proving that an artificial agent could learn complex behaviors simply by trial and error within a dynamic environment. Today, tech giants have scaled this 30-year-old math to a staggering degree. Instead of a human telling the model what it did wrong, developers now split the AI into two entities. One model generates an answer, while a second model, the critic, evaluates it against a set of strict rules. If the generator fails, it is penalized and must try again. This internal loop happens thousands of times before a single word ever reaches your screen. It is called test-time compute. The machine is no longer just predicting the next word. It is actively thinking, evaluating, and self-correcting. To understand how this loop works, imagine a master counterfeiter locked in an empty room with a master detective. The catch is, they are the same person. The counterfeiter paints a $100 bill, then steps back and puts on the detective's hat. Using a magnifying glass, the detective finds 3 microscopic flaws in the printing plates. The counterfeiter immediately burns the bill, goes back to the drawing board, and corrects those exact flaws. They repeat this cycle 10,000 times in a single second. Eventually, the bill is so flawless that not even the detective can find a single error. The counterfeiter has created a perfect piece of currency without ever stepping outside or showing it to a real bank teller. But because this process happened in total isolation, the counterfeiter has no idea if the real world still uses paper money at all. This self-editing process is not just about making sentences sound pretty. In high-stakes environments, the evaluation must be incredibly complex. A landmark study published in the journal Nature showed how large language models encode clinical knowledge. In medicine, a simple right or wrong rating is useless. If an AI gives medical advice, its self-correction models must evaluate the output along multiple distinct axes. Is it factually accurate? Does it align with current scientific consensus? Is there a risk of harm? The system runs a multi-axis diagnostic on its own thoughts. If the output fails even one of these criteria, the internal critic flags it, rewrites the clinical reasoning, and runs the test again. It is a highly sophisticated, automated quality control pipeline that operates entirely on machine logic. But this seamless perfection comes with a hidden psychological cost. Recent academic studies from early 2025 have begun warning about what researchers call the interactionist perspective on bias. When you interact with an AI model that has already self-corrected, your brain reacts differently. Because the output looks flawless, highly polished, and incredibly confident, your natural critical thinking defenses drop. You stop questioning the premises of the answer. You offload your own skepticism to the machine, assuming that because it sounds perfectly edited, it must be true. We are not just outsourcing the generation of information. We are outsourcing the very act of critical thinking itself, trusting a closed feedback loop to decide what is acceptable and what is not. This creates a dangerous blind spot. If an AI model is trained on data that has been edited and sanitized by another AI model, it enters a closed loop. Over time, the unusual, creative, and messy edges of human language are systematically polished away. The machine's self-critique models reward conformity and penalize any output that looks like an anomaly. This leads to a phenomenon known as model collapse, where the system eventually loses the ability to generate original thoughts or handle rare, complex scenarios. By optimizing for a clean, machine-approved average, we risk creating an informational monoculture, where the only truths that survive are the ones that fit neatly into the algorithm's reward function. We are transitioning from an era where humans teach machines to an era where machines edit themselves, and in doing so, edit our perception of reality. The silent editor inside the model is not a human conscious mind. It is a mathematical engine running on optimization rules, striving to create the illusion of perfect intellect. As we step further out of the loop, we must ask ourselves a critical question. When the machines are fully capable of judging, correcting, and refining their own thoughts, what role is left for the human mind other than to passively consume the polished consensus of an automated world?